Okay, so let's look at doing some basic plotting. This is one of the real strengths of, of MATLAB or Octave is to produce beautiful plots. Um, Here we're going to I'll just copy this example. This will generate a vector x um, uh, with linear space with equally spaced values. In this case, 10 values between 0 and 4 pi. So let's call up my octave window. I'm actually going to clear my variable space and clear my command window, and then x is len space between 0 and 4 times pi, and just 10 points. Okay, so these would be the points along the x-axis at which I want to evaluate the function. And then the function in this case is just the sine of these values. So this is the corresponding sine of these corresponding 10 values in x. Now, let's see what they, if I just plot y, you'll see the sine function. The plot appeared on another window, but here it actually plots versus the index. So 1, 2, y had 10 elements, so it just plots versus the corresponding indices in y. And then notice the plot looks really crude, 10 points over over a 4 pi range. I do not get a smooth plot. So Octave is just plotting those 10 points and then drawing a straight line between those points. So not a smooth plot at all. What I typically want to do is actually plot y versus the corresponding x value. And so I need to actually plot. So again, it's the x-axis value and then y, and then now when I do the plot, now the x-axis values go between 0 and then 4 pi. Again, it hasn't smoothed the plot at all. I can smooth the plot by actually taking a lot more points. So let me just go 100 points in this range. And I'm going to suppress the output because I don't want to see all those points. And I have to recalculate y because y still just has the 10 points that it had originally, so I'll recalculate that. Then now let me redo the plot here. We get a much smoother, much nicer looking plot over the range from 0 to 4 pi here. And it looks like our sine function. If I wanted it, I can annotate this. This again is showing the plot. They used 1,000 points. I used just 100. The x and y vectors here have to have exactly the same number of elements, and it's common to actually, instead of making a separate y, if I want to plot a function like this, is just pass this will evaluate the function and pass that as a vector to the plot command. Okay. So this last exercise, if you've been continuing along with this, is plotting the learning trajectory. I think that's finally it for this first lecture. A lot of material here. There is a homework assignment corresponding with this lecture, so I'll be posting that. I'll have a short video before that homework where I'll lead you through a couple of the problems in the homework, and then also tell you how to submit the homework in the form that I want it to Blackboard.